going to be looking at 2.4 pathway problems. We're going to look at how do we solve problems where it's asking us how many routes are there from point A to point B. Or they'll give us a diagram and we have to figure out how to get from point A to point B, how many ways that is. What's really cool is that there's a number pattern that was developed by Pascal. It's called Pascal's triangle, named after Blaise Pascal, who's the famous mathematician and philosopher. And he used this pattern to solve pathway problems. And it's a really unique pattern. How it starts is that on the outsides, they get ones. And then as you progressively get larger in the triangle moving down, you're developing these other numbers. And they come with whatever the two numbers above would add to. So a 1 and a 1 adds to 2. For here, again, the perimeter gets 1 on the outsides going down. This number is a 1 plus 2 and a 2 plus 1 to get the 3's. A 1 plus 3 is a 4, 3 plus 3 is 6, 3 plus 1 is 4, and so on. We're going to use this principle for adding to get the number of pathways. Here's how we start. Whenever you have a shape, we are going to have a starting point. And it can either go from the top left corner to the bottom right corner, or you could work from the bottom to the top. Does not matter. As long as you've got a starting point. The first thing you're going to do at the starting point is draw in these nodes on the line that comes out of our starting point. So notice that this top line and this line going down are the only two that come out of the starting point A. Then what we are going to do with these points is we're going to put number ones, just like Pascal's triangle, the ones. It's our starting point. Then next, how we're going to build our other nodes is we are going to draw in the node, and then what two numbers come into that? So a 1 and a 1 add up to 2. Okay, and here I'll go to this node, and I have a 2 and a 1 that will make a 3. And for here, a 1 and a 2 make a 3, and then a 3 and a 3 make a 6. So there are 6 ways that we can get from A to B. If I were to draw this out and just show you the number of ways to get from A to B, I'll show you what it's asking us to do. Okay, and I'm just going to use some different colors to show you. I could go from A to B taking this route. Okay, I could go from A to B taking this route. Okay, so that's 2 ways. I could go this way. That's the third. Okay, or I can go down and over, so that's the fourth way. I could go here. There's the fifth way. And then the last way would be from here all the way over and down. That's not the color that shows up the most. But here's the 6 ways mapped out to show you that it does work. And we don't want to do that for each and every question because some of our pathways are going to route is going to give us like a number 100 or more. Let's practice this again. How many routes from one point to another? So here I'm going to either go from A to B, or I can choose to go from B to A. It does not matter. If I choose to go from A to B, I am going to put my starting nodes on the lines that come out of point A. So that would be these positions here. And I am going to place the number 1 on all these nodes. Next, I'm going to start using Pascal's triangle, where I am going to calculate the value to the next node by adding what's coming into it. So a 1, and a 1 make a 2. A 2 and a 1 make a 3. A 3 and a 1 make a 4. A 4 and a 1 make a 5. Okay, come down here. Let's start here. A 1 and a 2 is a 3. A 3 and a 3 make a 6. 6 and a 4 make a 10. 10 and 5 is 15. I want to stop here a second and just highlight how I am recording the number. If the node that I'm trying to find is in the top right corner, then I am going to imagine that this square is divided into 4 sections. And I am going to limit where I write my number to fit in a quarter section of this square. The reason I want to do that is because I will have students write a big 6 like this. And when I go and look at their work, there will be errors in their adding because they won't know what node did that 6 stand for. Whereas if you can limit where you visualize it into quarter sections, and if I'm doing a number like a 4, that would be a 3 and a 3. So if this would have been a 3 and this node would have been a 3, then it would be a 3 and a 3 make a 6. So I'm limiting it to be in that quarter section so that it's easy to see and not mix up what you're doing. Okay, let's continue. So a 1 and a 3 is a 4. 4 and 6 is 10. 10 and 10 is 20. 20 and 15 is 35. Okay, back down here. A 1 and a 4 is 5. A 5 and a 10 is 15. 15 and 20 is 35. 35 and 35 is 70. A 1 and a 5 is 6. A 6 and 15 is 21. 21 and 35 is 56. 56 and 70 is 126. So 126 ways, for example, 2. Okay, next question. So what I noticed that's different about the train station to football stadium is it's not a complete rectangle. There's pieces taken out. And same thing follows. We're going to start by putting nodes on the lines that come out of our train station, directly out. And then I am going to now start adding. So a 1 and a 1 is a 2. 2 and a 1 is a 3. 3 and a 1 is a 4. And look at here. This node right here only has one line going into it. So it's a 4 plus nothing is a 4. So this would be an area, this would be one where I'm going to just circle here because it's going to be one where what do you do when it has just a single? There's just one line going to a node. And that would be where you would just continue with a 4 plus a 0 is 4. Okay, continue on. A 1 and a 2 is a 3. A 3 and a 3 is a 6. 6 and a 4 is a 10. A 10 and a 4 is a 14. A 1 and a 3 is 4. A 4 and a 6 is 10. A 10 and a 10 is 20. A 20 and a 14 is 34. Here, a 1 and a 4 is 5. A 5 and a 10 is 15. 15 and a 20 is 35. And a 35 and a 34 is 69. Okay, coming here, here we have the same scenario like we did before, where it's just one line coming into this node here, and it's a 15 plus a 0 is 15. Just making it a different color so that it stands out. It's a little different than what we have before. A 15 and a 35 is 50, and a 50 and 69 is 119. So 119 paths can be taken from the train station to the football stadium. Here's our next example. So the scenario that could come with this example right here is where you are moving from one point of the city to another, and potentially you could go over a bridge or take another, maybe there's two bridges or something that you can look at, and then from there you are continuing on with your path. So we're going to start the same way. Decide if you're going to go from top to bottom or if you're going to go from the bottom up to the top. So once you decide that, you are going to put nodes to go in the starting lines. So the starting lines that come out of it, and put ones. Okay, and now start counting. So a 1 and a 1 is a 2. A 2 and a 1 is a 3. And a 3 and a 1 is a 4. A 1 and a 2 is a 3. 3 and a 3 is a 6. A 6 and a 4 is a 10. Here's the area we need to now know what do we do. To get to this node, it's just one item going into it, and it's a 10. Here it's a 10 and a 0, so 10. And then our next one that's going to be important is right here. A 10 and a 10 is a 20. This is as if we are starting all over again, but we're starting all over with the number 20 now instead of the number 1, because we have to take whatever that value was up at the top here. And then we are just going to write in the 20s. Once you get the hang of this, it's super easy. And it's actually quite fun to do. Okay, now we can continue. A 20 and a 20 is a 40. A 40 and a 20 is a 60. A 60 and a 20 is an 80. 80 and a 20, 100. 20 and a 40 is a 60. A 60 and a 60 is 120. 120 and 80 is 200. And 200 and 100, 300. A 20 and a 60 is 80. 80 and 120 is 200. 200 and 200 is 400. 400 and 300 is 700. So there are 700 ways to get from top to bottom here. Okay, here's another example here. This example is unique because it has a section of it that is taken out of it. So what do we do when we have a section like that? Let's start and just get the paths numbers in, and then we will, until we get to that point, and then we'll look at what we do. So same thing, start by going to where I'm starting from, put in the nodes and put the number ones that go out of the starting point. Next, let's go and start doing the pathways. So a 1 and a 1 is a 2 and a 1 is a 3 and a 1 is a 4, and then just like the other ones, only a 4 is coming into it, so that is a 4. Okay, a 1 and a 2 is a 3. 3 and a 3 is a 6. A 6 and a 4 is 10. And a 10 and a 4 is a 14. Okay, here, a 1 and a 3 is 4. And a 1 and a 4 is 5. So I can get up to that point no problem. It's going to be now what do I do? So here, let me grab a different color. I thought I grabbed purple. Let's grab purple. Right here. Here, it has a 10 coming into it. So we'll go 10. Now I'm going to jump back over to here. And this has a 5 coming into it. And then to get this point, we're going to do the 10 and the 5 is a 15. 10 and a 5 is a 15 for here. Once you get that value, we should be good to go to continue on with the pattern. So here, this node has a 5. A 5 and a 15 is 20. Okay, now let's jump back up to here. A 10 and a 14 is 24. A 24 and 15 is 39. And 20 and 39 is 59. There are 59 ways to get from A to B. It's not bad to see this in the different colors, that the purple and the yellow showing you where the hard parts are or problem parts are, and then how you would deal with that. Okay, we have done a question like this one here, but this one here is where the scenario would be that you're going to go from point A to point B, but you're going to make a stop at C. So this would be like I'm going from my home to school, but before I go to school, I'm going to stop at London Drugs to pick up some Advil. Okay, so this would be like I am doing that. Okay, so same thing. We're going to start by placing in our ones. So I'll put in my nodes at my starting point at A, and now put in my ones. Okay, next, let's go and start to add. A 1 and a 1 is 2, 2 and a 1 is 3, 3 and a 1 is 4. 1 and a 2 is 3, 3 and 3 is 6, 6 and 4 is 10. A 1 and 3 is 4, a 4 and 6 is 10, and a 10 and a 10 is 20. Okay, next. This is where we were before on that other example. So at this point here, it is a 20. So that means that these will get 20s. And then we continue adding. A 20 and 20 is 40. And a 40 and 20 is 60. A 20 and 40 is 60. A 60 and 60 is 120. 120 ways to get from A to B. This question is the same, but we have it on a large grid. So what we are going to do is map out the areas that we are going to use. I am going to go from A to B, but through point C. So I am going to draw my outside lines here to get from A to B, stopping at point C. And now we can start to plan. So these are going to be where my ones are. Okay, and now start Pascal's triangle. A 1 and 1 is 2, 1 and 2 is 3, 1 and 3 is 4. 2 and 1 is 3, 3 and 3 is 6, 6 and 4 is 10. 3 and 1 is 4, 4 and 6 is 10, 10 and 10 is 20. 4 and 1 is 5, 10 and 5 is 15, 20 and 15 is 35. Just like we did in the previous example here, we're going to take the 35 and extend it out on the perimeters coming out of point C. And then we're going to start our adding again. 35 and 35 is 70. 70 and 35 is 105. Okay, 35 and 70 is 105. 105 and 105 is 210. 35 and 105 is 140. 140 and 210 is 350. Okay, 40 and 35 is 175. And 350 and 175 is 525. 525 ways to get from A to B, stopping at point C. You will have a question like this on the worksheet. It doesn't give the directions, but you will see this point C in the middle, and that's what it's wanting you to do. All right, example 5. In chess, the bishop piece can move diagonally on the board and only move diagonally. Find the number of ways that the bishop can be moved to each square. All right, example 5. In chess, the bishop piece can only move diagonally. Find the number of ways that the bishop can move to each square. How many ways can it take to get to A, to B, to C, to D? And the bishop can only move on the shaded squares diagonally towards the A, B, C, and D. So what I'm going to do is start to build the pathway it's going to take. So it can only go diagonally, so it can't move back. It can only go in the one direction. That is not a very straight line. A little bit better. Okay. The reason I'm showing you this one is that you are going to get a chess or checkers board where you're going to be asked to do the same thing. And you will need to just build the grid for it, just like I'm doing here. So my suggestion would be is to put the nodes in the middle and then take a line and connect. Doesn't have to be perfect, just needs to be enough so that you can see those lines. All right. Almost done. Okay, here's our board. So I'm going to start to build with the number ones. So here's my starting point. So 1, 1, 1, 1, 1. Okay, now let's start to add. Let's pick a color that we can see. Orange will work. A 1 and 1 is 2. A 2 and 1 is 3. A 1 and 3 is 4. A 1 and 4 is 5. And then to D is just 5. Okay, next, a 1 and 2 is 3. A 3 and 3 is 6. A 6 and 4 is 10. And then a 10 and 5 is 15. There are 15 ways to see. Okay, here, this is a 3. And a 3 and 6 is 9. And a 10 and 9 is 19. So 19 ways to B. And then 9 up to A, and 9 ways up to A. Okay, so today you'll be working on a worksheet for pathways, and good luck with that.